Hello my dear students, welcome back to the IMS GATE Academy. So let's continue the foundation course on computer organization architecture. The last previous two sessions have taken some topic like a floating point number representation from the computer organization architecture. So in this session I'll be coming with another topics called memory organization. From memory organization we'll see the memory hierarchy in this session. So let's begin the session now. So from memory organization, I'll be giving now what are the topics which we are going to study upcoming event sessions also. So I'll be covering the topics from memory organizations or memory hierarchy. Memory hierarchy. The followed by we'll see the main memory. Main memory. And the third topic is cache memory. Cache memory. And the fourth topic is secondary memory. Secondary memory. So these are the topics which I am going to cover from the memory organization. Hi Nikhil. See, the memory organization which I kept, there are more majorly four important topics which I am going to cover. You can see the upcoming two sessions also I'll be continuing this topic only. So particular today's session, in this session we'll see the memory hierarchy and what are the things we'll see from this memory hierarchy you observe. So memory hierarchy. The first of all we'll understand the importance of the memory hierarchy. Importance of the memory hierarchy we'll see, followed by the types of memory, types of the memory components, memories, types of memories. Then characteristics of memory hierarchy, and we'll see the performance of memory hierarchy. Lastly, we'll see some problems on memory hierarchy. Problems on memory hierarchy. So in this session, these are the topics which I am going to cover. We'll understand the importance of the memory hierarchy and what are the types of memories are there. Why these are the memories need to be arranged in the memory hierarchy. What is this important? What is this objective? The various characteristics of the memory hierarchy. Also we'll see the performance of the memory hierarchy. We'll end up the session by discussing some few problems. I hope this is going to be beneficial for you understanding even other topics also. And from GATE examination point of view, if you consider, we can expect the one or two questions from this area. I hope you understand all of you. Fine. So let's begin this session start with the memory hierarchy. Memory hierarchy. What is this memory hierarchy? Please understand all of you. The few points I mentioned here, see. Memory hierarchy is like arrangement of different types of memories. Understand please all of you. Arrangement of different types of memory hierarchy is nothing but what? So arrangement of different types of memory is called what? Memory hierarchy. So what is the purpose of arranging this different types of memory in terms of hierarchy? To reduce average access time. Sir, what is this average access time? We'll understand the point wise with examples we'll understand more. So the major objective of arranging the different memories into hierarchical form is to know, you see I mentioned, matching of data transfer rate of the faster processor to that of lowest level memory, that is a disk is secondary memory. Matching of data transfer rate, please understand, matching of data transfer rate to the faster processor means CPU and lowest memory secondary memory. This is a would be this is a pure electronic device, this is electromechanical device. This nature if see in terms of data transmission speed, if you see this CPU is this falls like this, the secondary memory will be. So we have to make it like I want to compensate the speed differential between these two components. Means the moment processor asks the data to the secondary memory to fetch, so this should be available immediately. So this is the major reason to arrange the different memories in terms of hierarchy. So this definitely is going to be reduces the average access time of a instruction data. That need to be understand. I hope the statement is clear all of you. Yes. So the statement is clear, right? Now if I ask question, What are the types of memories are there? Memories, memory components in the computer system. Understand all of you. Memory. What is the purpose of memory? Yes. Somebody could comment. What is the purpose of memory? Yeah. In the computer system, you might have seen various components or various types of memory you might have seen, right? What is the purpose of this memory? The purpose of memory is to keep or store the instruction data. The programs, you understand, programs or data. Data can be the executable, which is executable, non-executable things also. We want to store our information in the computer system, so that is only possible with what memory components only. These memory components are broadly classified into two types of memories. Broadly classified into two types. So memory is broadly classified into two types of memory. Two types of memory. The first type, first classification is a main memory. Main memory. First classification is what? Main memory. This also known to be primary memory. Primary memory. Primary memory. Main memory or primary memory, understand. The second classification of the memory is what? Secondary memory. Secondary. Secondary is also known to be auxiliary memory. Auxiliary memory. Auxiliary memory. Please understand all of you. The memory is broadly classified into two categories, primary or main memory, the secondary or auxiliary memory. So I ask you, all of you, please comment, what are the memory components which comes under the primary or main memory type? Yes, I am waiting for your comment. Yes, all of you. Respond. What are the memory component which comes under primary or main memory type? Like you have seen, like no, the RAM, random access memory, RAM, or ROM, read-only memory, read-only memory. Most of the students have a confusion. ROM, read-only memory, whether it is comes under primary type or secondary type. Please do not misunderstand. This also comes under primary memory, also known to be main memory only. So we will see the differentiation, the difference between RAM and ROM further classes, right? So the ROM also comes under what? Primary type only. And another type of memory is called cache memory, cache or cache memory, you can call cache memory. And the registers, these registers are the memory elements which part of the processor, CPU, part of the processor, which can hold maximum in terms of words only, not in terms of more than word. It can store in terms of words. The registers are part of the CPU. Okay, cache memory is another type of memory. ROM, read-only memory, RAM. This all comes under primary type memories or main memories one. So when it comes to secondary memory, so well-known thing called hard disk drive, or floppy disk drive, or compact disc, or DVDs, or pen drives. Please understand. So pen drives, all comes under secondary or auxiliary type memories. Secondary or auxiliary type. So you can ask me question, sir, what exactly differentiation? So like what is the distinction between like main memory and secondary? Means what parameters are, what basis we are classifying this memory into two categories, primary and secondary memory. Please understand the way of construction. So these memories are constructed with semiconductors. So this nature of the, please understand, nature of the primary memories are semiconductor devices, semiconductor memory components also you can tell. So the nature of the secondary memory, auxiliary memories are, it could be optical or electromechanical. Electromechanical or optical devices. Optical devices. Please understand. Hard disk, if you take, or floppy drive disk, if you take, these are magnetic devices. If you take CD, compact, this is an optical device now, optical type. Please understand. This is the differentiation between the primary memories and secondary memories, which are semiconductors. Some are them constructed with in terms of flip-flops, some are the data information stored in terms of like charges in a capacitor form. Like if I take RAM further classified into static and dynamic RAM. If I take static RAM, generally designed with the flip-flops. So the flip-flop is a basic element which can store either 0 or 1 bistable, right? So some component of the RAM type, the static RAM, is designed with the flip-flops. The RAM, dynamic RAMs, which are generally available in computer system as a main memory, which are constructed like the information is stored in that in terms of what charges in the capacitor. When it is comes to this like mechanical or like magnetic or optical devices, so this differentiation would be there. And these memories are, please understand all of you, so these memories are volatile memory, volatile memory. Yes, somebody could tell what is the meaning of volatile memory? These are the non-volatile memories, non-volatile memories, volatile memory. This non-volatile, the first category is volatile memory. What is volatile memory? So data cannot be present in the computer when the power is off. When the power is off, no data in the computer system. That component, RAM or ROM, or if you take so like cache memory, so data will not present when the power is off. So non-volatile means what? The permanent data, like the RAM data can be remaining. So remaining can remain present even power is not there. That differentiation also we can understand. So in terms of access time, if you observe these two components, these components are faster, these components are slower. So what rate will be there? Generally, access time of any word in this component goes in terms of nanoseconds per word or some microseconds per word. But same thing, if you want to capture from the secondary components, may takes in terms of milliseconds. Like when you see the properties or characteristic of the secondary memory, so average time required to read something from the secondary memory may goes to the milliseconds form. So that differentiation would be there from primary memory to main memory, right? Primary memory to secondary memory. So this is a differentiation which you observe. Fine. Now let's move on to the hierarchy. What is the hierarchy said? Hierarchy means what? Arrangement of different memories. Arrangement of different memories. Purpose what? To reduce the average access time. Sir, you can ask me question. Sir, why this many types of memories required to store our information? Why can't we use only one type of memory? Let's take RAM only. Why can't it go with only RAM? Why is the need of secondary memory? So these are the doubts. Please understand. As per the, you might have studied as per the Van architecture. As per the Van architecture, generally we use for the majority architecture. If you see, that is falls under what Van for all general purpose computers. As per the Van architecture, any program, that's program instruction data you want to compute with the computer system, that program must be reside in a main memory prior to the execution. Initially, our all programs or applications is secondary memory only. From there, the program need to be keep into main memory further execution. You can ask me a question, what is the need of, sir? Why can't go with only secondary memories? Why can't go with only primary memories? What is the need of two types of memories here? Please understand. If I go with only primary memories, since which are volatile memory, primary memories are volatile memory. Once program execution over, application is over, suppose the data you want to keep it further, or programs you want to keep it further, general data, general information you want to keep it further in a computer system, so that is not possible with the primary type, since the nature of these memories are volatile. Then you can ask me, sir, go with all secondary memories only. Why you are taking the primary memories? The reason comes, secondary memories are slower memories in comparison to what processor. Processor is an electronic device, this is electromechanical optical device. The difference will be very high in terms of speed. Difference is high. So now you understand processor, if a processor want to fetch any instruction data from secondary memory which you kept, it may take many clock cycle to fetch it. So that response will be less, throughput may be less, right? So we need faster memories which can store active material, active programs to be executed right now. So that is the reason we need primary types and secondary type, both we require. This is one reason. Other reason you understand, so primary memories are costlier, these memories are cheaper, right? So these are the reasons would be there, reasons are there, so that we must have all types of memory. Then when you have all types of memory, how to arrange them is important. Arrangement of this memory should minimize the average access time. What this average access time goes, we'll observe now. What this average access time, how this memory hierarchy will reduce the average access time, that we can observe right now. Yes, all of you, look the point here. So as per the Van architecture, if you see, as per the Van as per the Van architecture. Okay, if I follow Van architecture, what is saying that the program, if it is there, this is a program. Please understand. So program, okay. So program has set of instruction, instruction 1, instruction 2, instruction 3, instruction 4. Please understand. Okay, instruction 100 are there. Okay. So this program, if I want to compute with the CPU, if I want to compute with the CPU, central processing, if you want to execute it. So this program P, initially it is in disk, right? Initially it is in disk. So program is on disk. I want to execute it. So what I said you, processor, if you processor want to fetch an instruction which are present in disk, it takes more time. That is the reason what I am saying that here is a main memory, here is a main memory. So program P you have to keep in main memory prior to the execution, so that processor can fetch instruction and data, execute it, like fetch instruction, data and execute. So now processor can access directly with the main memory, not to the secondary memory. This is the nature, this is the architecture of the Van Neumann. This we follow. Fine, all of you. So now understand the situation, like so you should understand one point here, 90% to 10% rule, 90% to 10% rule. What this 90% to 10% rule says that, you look at this program. This program has set of instructions like procedure, methods, functions also included. So generally we keep in secondary memory. When you want to compute that, the entire program will load into main memory, will start the execution. The processor will fetch instruction data which present in main memory and executes, right? Let's take main memory access time is 100 nanoseconds. Please understand. Main memory access time 100 nanoseconds. Getting my point, all of you? Main memory access time 100 nanoseconds is there. Suppose here is somewhere, suppose understand, somewhere there is a loop as on that. For loop is there, okay, loop I equal to 0, I less than 100, I less than 100, I plus plus, okay, I plus plus. Let's take some declaration int x is there, x equal to x plus I, therefore forming as on that. This is there. There is a loop is there as on that. All of you please understand carefully. So now this loop is going to be repeated how many times? Yes, the loop is going to be repeated how many times? 100 times, right? Because I equal 0 to I less than 100. 100 times this loop will repeat. Means 100 times this instruction x equal to x plus 5 will run. Addition of the x and I. Each time I is different, right? Updated x value and updated I value you have to add and store in x. Summation of from 0 to like this will go. Correct or not? You have to read this I and I, x and I, and substitute, like perform the addition and store it, this will happen, right? But same instruction will repeat how many times? 100 times. Instruction data present in what? Main memory only. When I equal to 0, the CPU will fetch instruction or data from here. So taking how much time? Access, one time access is 100 nanosecond. So when I first time access 100 nanosecond required, the second I equal to 200 nanosecond, I equal to 300 nanosecond. So like 100 times repeat, 100 into 100 nanosecond time is required to compute. So this part of the code only, I am not worrying about this part of the code. Some part of the code where loop is presented, this repeated several times. In order to compute this one, so now this 100 into 100 nanosecond, right? Yes or no? 100 into 100 nanoseconds time is required to run the particular program only, right? Now understand, all of you. From your programming experience, you can comment me, all of you please. You just comment me. So did you ever experience that your program may contains like loops, some methods, the method will be repeated several times, like especially recursive functions. Recursive functions calls many times same code only, same code will repeat several times, right? Most of the cases we experience are programs containing the instruction or data or method, something which will repeat several times, especially like loops, correct? So with that we can understand, with this observation, so 90% to 10% rule came out means this observation. What is that 90% to 10% rule? Most of the case, please understand, most of the case, a program spend 90% of its time on 10% of the code. Do you believe this statement, all of you? Let me write the statement of this 90% to 10% rule. A program a program spend 90% of its time 90% of its time on 10% of 10% of 10% of program code. Okay. So this is 90% to 10% rule says a program is spending most of the time on some part of the code only. You understand? There are 100 lines. Some lines, suppose I1, I2, I3 all are one time only executing, but particular code is there, that is for loop. This repeating how many times? 100 times. Now this program particular spending more time on where? This area only, right? Yes or no? This area only. But because of this area, you understand how much time has taken 100 into 100 nanosecond required or not? Because same thing repeated 100 times here. So this time how can be reduced? This time how can be reduced? Now see, based on this observation, so they introduce, please understand, they introduce new type of memory, called cache memory. Cache memory was introduced. Cache memory was introduced. What is the purpose of this cache memory? The instruction or data which is repeating, please understand, frequently repeating. Are you getting my point? Processor is fetching a instruction data which is repeatedly executing. Those data, if you keep in this cache memory, this is going to be reduces the average access time, not individual access time. Let's observe with the cache memory how this will reduce. Look, all of you. Now here is a disk. Please understand. Here is a disk. Okay. As per the Kahneman architecture, our program will be initially in disk. Now we will be loading into main memory for execution. This is a main memory. Please understand. So this program P is loaded here. Program P is loaded into main memory. Please understand. Here is a processor. CPU. Here is a processor. Now there is a code program. Program is there. Okay. Program. Okay. This program A is spending. Please understand. Is spending 90% of time on some part of the code. Please understand. Some part of the code. So this code means some instruction is repeating 100 times. So loop is repeating 100 times. Assume that. As I mentioned, here this loop. Loop is repeating how many? 100 times repeating. Okay. 100 times repeating. Please understand. This is repeating how many times? 100 times repeating. Please understand. So now see. Now if I introduce a cache memory, how this is going to be reduced, just will observe. If I introduce a cache memory, how this is going to be reduced? Look all of you. Whenever a program want to start execution, our processor will fetch instruction from memory only. Okay, let's take that loop only. I want first access the x value, initial value of x I have to access. So that for that x I have to add it. Then store in x. Store will x nothing but x you have to store in main memory only, right? See, when I write this one, you have to read the x value from main memory, add to I value. The results you store in x nothing but you are storing in memory only. Okay. So when I equal to 0, I am writing when I equal to 0. So that x is accessed from main memory to this one. It takes how much time I mentioned? 100 nanosecond time required. With the cache, what I can do, the first time when you access now, that x value can be stored. Let's say initial value of x is 10, assume that. Getting my point? Initial value of x 1, 10, that is given to the CPU also. Given to the CPU. When I equal to 2 happens, now x value, please understand, x equal to x plus I did, right? When I equal to 1, when I equal to 0, x equal to x plus I done. The results is modified to here only, 11 only. It is not reflected to the here is x equal to 10, initially 10 only. Now when I equal to 2, this you have to increment only, increment. So you continue with till what? Till I equal to 100, 99, okay. Now suppose let's take cache access time is 10 nanosecond, means first time when I equal to 0, you get the instruction from or data from memory, that may takes 100 nanosecond, that you keep into cache memory. Later, remaining all the time, so processor can access directly from the cache memory, not from the main memory. So now, so this access time will reduce or not? This access time will reduce because remaining from I equal to 1 to 99, processor will fetch a data or instruction from the cache memory, not from the main memory. So that all thing can be updated here only. Final value I can update here. So that with that what happens? Access time, if you take for this particular code only, the first time required 100 nanosecond, later 99 times, 99 required what? 10 nanoseconds only or not? Yes or no? This 100 nanoseconds plus this 900 nanoseconds, right? 990 nanosecond. This gives how much? This gives how much? 1090 nanosecond. 1090 nanosecond required for this particular code to be run if I use a cache memory. So now see, so this is reducing the average access time, not individual. Individual information has to come from main memory only. Any material means material nothing but your instruction data which is repeating more than one time. So that material if we keep into cache memory, so that will reduce access time. Are you getting my point? Suppose if I want to write it, no, time without cache memory, without cache memory for that particular instruction, how much happen? 100 into 100 nanoseconds happen, right? So now time with cache memory, how much happen? 1090 nanoseconds, right? Now if I want to check the speed up, so speed up we achieved with this one, time without cache by time with cache, 100 into 100 nanosecond divided by 1090 nanosecond. Can I do it or not? It will give, right, this many times faster than without cache memory. This giving the speed up factor. Means if I use a new type memory, if I introduce the cache memory, so that drastically reduces average access time when that cache is containing the instruction data which are repeatedly accessed by the processor. Fine. Now understand, main memory, in the main memory, that's RAM, main memory is RAM. In a RAM, apart from RAM, we introduce another memory called cache memory, then secondary memory also there. Now these three types of memories, 3 or 4 types of memory, we have to arrange them in hierarchy form. So this hierarchy will definitely reduces the average access time. I hope you understand the importance of now memory hierarchy. All of you, please comment it, everybody. Fine. So I have shown this example to understand, if I introduce the another type of cache memory, this arrangement will reduce average access time. So this also came into picture by observing this one, because most of the time my program is spending on small amount of the code only. Now look at the hierarchy. What this hierarchy? Please see how we are arranging. Like now I'm showing the diagrammatically. See. Okay. Now see all of you. So this diagram shows, like now I'm like dividing into some 3 parts. I'm dividing here. Here is a cache memory. Please understand. I'm placing cache memory in the hierarchy top. Then next level is what? Main memory. Okay, main memory. Then last is the disk, magnetic disk. I'm taking disk here. This disk. We can say level 1, level 0. This is about level 0 memory. Level 1 memory. Level 2 memory. Like level started from 0, 1, 2, 3. We can write it. Or you can start level 1, 2, 3 also. So depends on the number of levels. I am writing 0, 1, 2 like this. Understand? So you also see the diagram. From this diagram we can understand. So this area, cache area small, here disk is area more, right? Means this indication, see, this diagrammatic representation shows size of the memories, which is smaller size, which is a largest capacity memories also we can observe here. So now understand, main memory is a processor, his CPU is there. CPU can fetch a instruction data from first, you can try from cache memory. If this is present, that can be taken. If those data, if it is not present, ultimately processor has to fetch a instruction data from main memory only. Fine. So now data will move from, please understand, data will move from disk to memory, right? So memory to cache memory to CPU it will go. Getting my point? Disk to memory, memory to cache to CPU registers. Now processor will execute the instruction data in the register level only. So because you know, operations, the final execution will happen with the register level only. So that registers contains in terms of words only. So now look all of you. Now look, some important point we can observe. Sir, what this disk is containing? Disk, please understand what disk is containing. Magnetic disk contains the program and data only, right? So that data, please understand, data we in terms of segments we call segments. Segments are pages, please understand. Segments are pages. which will move, please understand, these segments are pages which contain the disk will moving into second level, that is main memory. Okay, it is moving into main memory. So what I'm trying to say here, okay, initially data in secondary memory only, so that data will move to main memory, from that some part will move to cache memory, from that some part will move to CPU state for execution. So what rate it will go, means what level it will go, I am saying here, from secondary memory to main memory, data will move in terms of pages or segments. In terms of pages or segment, so this pages size would be in terms of 512 bytes to 4 KB, even more also, 512 bytes to 4 KB, even in more also. Generally I given general range I given, it can be more size also can come from disk to main memory. Now memory, in a main memory, data is arranged in terms of blocks, please understand, in terms of blocks. Getting my point? Blocks. So now segments or pages broken up into blocks. So these blocks, please understand, these blocks, so will move to cache memory, will move to cache memory, please understand. Blocks move to cache memory, fine. From cache memory, please understand, these blocks will move, divide into words. So from cache memory, the block of the words, block of data will divide into words. The words are moving into CPU registers. CPU registers, please understand, CPU register. Now CPU start the execution on register level, please understand. So where the registers are part of CPU only. Like this registers also classified in two category: special type of register, general purpose register, which you might have aware it. Special type of register like program counter, accumulator, stack pointer, base register. So these are the special type of register like memory address register, memory data register, right? Now general purpose registers are used for storing data or data or address during computation. Okay, which are part of CPU only. Getting my point, all of you? So data will move from here to here, and they given to CPU register, they start execution. This is hierarchy form. This we call hierarchy form. See, different types of memory I arranged in some order, some hierarchy form. So data will be moving to CPU state now. Ultimate agenda to keep the memory program, so like memory components in a hierarchy is to reduce the time only, average access time only. That I shown you with example also. Fine. We'll see now some characteristic of a memory hierarchy, all of you. So you can put the subheading as characteristics, various characteristic of a memory hierarchy. Okay. Top level of the memory hierarchy is a cache memory. The next level is what? Main memory. Bottom level of the memory hierarchy is what? Disk I'm considering. So here is a CPU, here is a CPU. Okay. Even you can put like some other level you want to put it, you can put a registers also. A register may falls under level 0, then cache memory, then main memory, then disk. Getting? So this is the levels I'm writing, levels. Okay, levels. This is a level 0, this is a level 1, level 2. Please understand. So characteristic means some characteristic we can observe. What is the characteristic here? Time, access time, cost of the memory component, size of the memory component we can observe. Getting? T is what? Access time of a particular memory level, and cost of the particular level, and size of the particular level. Particular level means level 0 or level 1 or level 2. Please understand. Suppose you look, all of you, bottom to top, you see, bottom to top. So bottom to top I am considering, bottom to top. Okay. So I will see now, you see the time. Okay, tell me. So when I move from bottom to top, access time per word from this memory component will increase or decrease? Please all of you tell me. I am accessing the data from this area, bottom to top I am looking. Which memory component takes more time or less time? Access time. As I mentioned, main memories are faster, secondary memories are slower. Okay, this memory takes more time. Means when you are moving from bottom to top, access time will decrease, right? Decrease. The symbol indicates decrease. Access time decreases. Cost, see, cost. Cost of the memory component from bottom to top, if you see, bottom level memories are cheaper. top level memories are costly. So bottom to top, if you go, cost will increase, right? Size if you go. So upper levels are all having what smaller size will decrease. This is observation. Similarly, so top to bottom, if you see, top to bottom, so top to bottom, if you see, access time will increases, cost will decreases, size will increases. This observation we can made now. So this observation we can made on this memory hierarchy. Okay, whatever level of components if we arrange, so top level memory will be the costlier memory, size is smaller than the next level memory, This observation we can made on this memory hierarchy. I hope it is clear, all of you. I hope it is clear. Now we'll see some mathematical expressions for this one. Mathematical expressions will check the performance of this memory hierarchy. So we'll check the performance of memory hierarchy, all of you. Please understand. We'll check the performance of memory hierarchy. Okay, write them. Mathematical expressions for memory hierarchy. You can write let. I'm taking like, so let mathematical expression will write. Before that you write one point. Before that we'll write one point here. So ith level memory is physically positioned higher than the I plus 1th level memory in the memory hierarchy. What does mean? Suppose if I take I0 means level 1, top level, is definitely in physical format. If you see, it is positioned higher level than I plus 1, that was I am telling. With this respect, suppose if I take Ti, what is the Ti? And Ti plus 1. So Ti is ith level, Ti plus 1 second level, next level. From top to bottom you see, I plus 1. So now all of you please tell me, access time of ith level is, what is the relationship between this one, ith level, I plus 1 level? Access time, who is taking more time? Yes, I need a response from everybody. Yes. Ith level memory, what I am trying to say, ith level, this is so Ti, I plus 1 is there. Who is taking more time? Who is taking less time? So ith level is smaller than I plus 1 or not? So less than, this symbol I can write. This is a relation. Second one, size if you see, Si and Si plus 1, So who is larger? Who is larger? So I plus 1 is what? Larger. So this is also small. Third one, okay. Ci, cost, Ci plus 1, cost. Which one is a costly? Ith level is costlier than I plus 1. So this information you can capture. Next one, Fi and Fi plus 1 I am marking. What is the F? Frequently, please understand, frequency of accessing the frequency accessing the particular memory. So which is having the more frequency of access in the memory? Generally secondary memory we refer one time, main memory many times will refer, cache memory many times we refer, right? Ith level memory having the more frequency of access than I plus 1. This you need to understand. So next, fifth point. Look all fifth point, okay. I, capital I suffix small I, capital I suffix I plus 1. Here is high is what? Information. So information availability. Information availability. Tell me. Okay. Information availability at ith level and information is available at I plus 1. What is the relation? Should I write it? What is the relation? So that means which level having the more information? Obviously I plus 1. Then you tell me what is the relation I should write. Should I write less than or equal to, greater than or equal to? What symbol I should use? Please think and the comment it what symbol I should write it. Information available at cache memory is dash of information available at main memory. Other way understand, information is available at main memory dash of information availability at secondary memory. What relation should I write? Should I write less than or equal to what should I write it? Please understand all of you one important thing here, everybody. All these memory different components, this different component we arrange in hierarchy form. All these memory components do not contain the different information, please understand. All these memory components do not contain different information, please understand. What they contain? Same information only. See, whatever main memory, please understand, whatever main memory is there, everything available secondary memory or not. Whatever information is stored in cache memory, that is also available in main memory or not. Yes or no? So, all three levels, this hierarchy if you see, all three having same only. Suppose example, here is 100 GB is there, 100 GB is there. It may be 4 GB of data. So, this 4 GB is subset of this one only, right? Yes or no? This only. Maybe suppose 256 KB is there, 256 KB. 256 KB of cache memory, whatever content is, that is also available in main memory. Whatever 4 GB data, that is also available in secondary memory or not. So, this all components are not having the different data. We use them for storing same data only. What is the purpose, sir? To reduce access time only. You treat one example, I can tell you, like you can correlate that one. Suppose, so every home having the refrigerator. What is the purpose of refrigerator? To keep the vegetables and which are required, other things also we can keep it. Correct. Especially see the vegetable which can sustain 1-2 days only can be kept in refrigerator so that you can use for 1 week or something we can use for even months also, right? You observe vegetables, if we take vegetables, suppose one vegetable big market is there and vegetable small market near to your home will be there, right? And there is one more shop near very close to your house, small shops will be there where they keep few vegetables and with the quantity also less, and those vegetables also keep in refrigerator. If you see, the market is containing all the types of vegetables and in a good quantity, right? Yes or no? Yes or no, all of you? And the nearest to small market contains all the type of vegetable but in a small quantity. The nearest shop to your house is also contain the limited size of the limited number types of the vegetables and small quantum. In your refrigerator also like small quantity in terms of kgs of or 1 kg, right? But all the way having the same type of vegetables only. This big market, small market or shop, refrigerator, all are same only, not different. You also understand here. The disk having the more data, there's a big market like this, everything is available. Anything you want to compute, you want to execute, that should be there in that secondary memory. Without that you can run it. Some part you are keeping into where in main memory, means the program which are essential to be run, which are active to be run now, active programs you want to run, that you are keeping in main memory. Correct? From the some portion, like part of the program which is repeated by the process several times, so those code we can keep into cache memory, like accessing array elements, array keep on access, or any function call repeatedly calling, or loops, this data you can keep into what cache memory, so that frequently referred you can keep it, like a refrigerator, right? Refrigerator means when your mom is cooking, so she can go immediately that refrigerator, then access and do the, it's not required to go every day, every time to market, get the things and prepare it. It is available at your kitchen only. You understand, that way this is a cache will help us. You understand please. So like the refrigerator contain the frequently referred things. Correct or not? Cache memory kind of a frequently referred thing. What things are repeatedly accessed? Like example, if you say tomatoes or aloo, these are the things frequently used, so that you can keep in refrigerator or not, right? Yes or no? Similarly, like in a cache memory also, the part of our program which is going to repeatedly accessed by the processor we are keeping, so that will reduce our access time. I hope you understand this point, ma. Fine. So now look at this point here. So now see, information availability at ith level is subset. Please understand, subset. So like the subset to the what, I+1 to level, subset, because the subset, I should not write it less than, it is subset because subset to this, whatever ith level is, so that will always having I+1. This you need to understand. Fine. So this is the major characteristic of a memory hierarchy we observed, right? Now we'll see the mathematical expression which I mentioned, right? Now please understand this memory hierarchy performance. We want to see performance of memory hierarchy. Performance of the memory hierarchy is given by it ratio. Please understand, it ratio. So it ratio, okay. When you are arranging this memory components hierarchical form, the cache memory, essence of cache memory should has to perform well. If cache is performing well, then overall memory hierarchy average access time will be reduced. That's what we wanted to do, right? I shown one example. In that example, I kept the content which is repeatedly accessed by the processor. So that is always available, many times available in cache only. So cache is it. When the iteration of that particular memory is high, overall system performance, like overall hierarchy is good, means average access time is less. Understand here, it ratio. What I said, performance of the memory hierarchy is depends on the it ratio, given by it ratio. What is this it? It means, please understand, please, availability of referred information is at referred level of the memory, level I can write it. It means what is present. When I am referring into that location, present is it. So next one, miss. So non-availability, please understand, non-availability of referred information is at referred level is a miss. So now understand, it ratio gives what? Number of its. So number of its divided by, so number of its plus number of miss. So total references, this gives total references, right? If it ratio of the cache memory is good, then I can say overall memory hierarchy also good, I can say. Please understand. When it ratio is more, please understand, it ratio is directly proportional to one size of the memory or not? Yes, only size of the memory or not? It ratio is directly proportional to size of the memory. Secondary level, secondary memory is having the highest it ratio. Everything is present or not? Yes or no? If 3-level memory hierarchy, if I take, level 3 is having the highest it ratio, 100% it ratio. That is secondary memory. Size is more, right? Size is more, that is the reason it ratio also more. Getting? That's what I said now, one point. It ratio directly proportional to size of the memory. So I can say, suppose 3-level memory, 3-level memory hierarchy, if I take level 1, level 2, if I take level 3 memory, please, level 3, it ratio means if I take H3 as a it ratio, so this will be 1. It ratio of level 3 is 1, nothing but 100%, everything is available, please understand, everything is available. Okay, next point. So it ratio, please understand, it ratio is inverse proportion to T average access time. T average access time is average access time of 3-level system if I take. If it ratio is more the it ratio, average access time is less. If average access time, if you are getting more, nothing but what? It ratio is smaller. I said 2 important points, you have to note of it here, all of you, please. It ratio is directly proportional to size of the memory. More the size, more it ratio. It ratio is more, total average access time reduces or not? That's what we want to do with the memory hierarchy. Average access time we want to reduce, so that is only possible when it ratio is high. So this need to be understood. So further we'll see. Let 2-level memory hierarchy consideration. 2-level memory hierarchy. Let 2-level memory hierarchy in which T1 comma S1 comma and C1. Let me take one more also. H1 and C1 are the specifications of level 1. Okay, level 1 memory. Okay, level 1 memory. While please continue here, please understand. What is the T1? Access time of level 1. What is S1? Size of the level 1. H is it ratio of level 1. What is the cost? Cost of the level 1, understand. While T2, S2, H2 and C2 are the specifications of level 2 memory. So what I can say, 2 level memory hierarchy, right? Whereas a T is what? Access time of L1. S1 is size of the L1. C1 is cost of L1. Getting me? C1 is cost. H is it ratio of L1. This need to be understood. Fine. So 2 level memory system I consider. First thing, can I make it H2 equal to 1 by default? Yes or no? Why? 2 level memory system, bottom level memory is it, always it, right? Second one, if I want to know total size of the memory system, 2 level memory system I am considering 2 level, main memory, second memory assumption, or if you take 3 level also you can get the size or all the things. So 2 level total size, so for total size I am referring capital S. Okay, so that is S1 plus S2 only, yes or no? S1 plus S2 only, S1 plus S2. Similarly, third one, if I want to take average cost of 2 level system, average cost per bit, how much cost per 1 bit if I buy either level 1 or level 2, average cost if I want to know. How to write average cost? Total cost. So total cost of the 2 level memory system by total size I can take it, right? Total size of the system. How to obtain 2 level cost? So total cost system, can I add C1 plus C2 by C1 plus C2? Can I add C1 plus C2? This is wrong. Please, why it is wrong? What I am average cost per bit or cost per byte if I want to know. 2 level memory system. Please, I cannot write C1 plus C2. Reason, suppose main memory, secondary memory, see, cost per bit is different with the 2 level memories because secondary memories are cheaper memories. Main memories are costlier memories. Example, see, 2 GB RAM generally if you want to purchase, you may need to spend 1500 2000 rupees. To same 2000 rupees spend, you may get 500 GB hard disk, correct? So 2 GB and 500 GB, understand difference is there, right? So now I should write it like, total cost means the cost with respect to size only, plus C2 plus S2 divided by S1, yes means capital S total size, yes. So this will give the cost per bit, you can see. Similarly, if I ask question all of you, average access time, please. T average means what? Average access time with a two level system. Should I take, can I write like T1 plus T2 by 2? Average cost we got, average time. 2 level memory system is there, ma. Whenever reference comes from the processor to fetch instruction data, means address, whenever a process want to fetch instruction data from this 2 level memory system, data may come from level 1 or data may come from level 2. What is the time required? What is average access time required to get a instruction or data from this 2 level system? So that I was asking, can I write it T1 plus T2? T1 is the level 1 access time, T2 is a level 2 access time. So by 2, can I do it this one? So this is going to be absolutely wrong. Please understand. I cannot take average T1 plus T2 by 2. So this something else need to be done. What is something else? Because if I take 2 level memory hierarchy, first of all we search because connection, based on the connection this can come. How the components are connected? Are they parallelly connected to the CPU? Are they connected, the hierarchy is level by level or something else? Correct? Are you getting my point? So this average access time of a 2 memory components can be obtained the way of memory components are connected to the CPU, connected to the processor. So that we'll observe right now. Okay, this need to be find out average access time. Now see. So now see case 1 I am considering case 1. Please observe now. Case 1 I am considering case 1. Case 1 means what? Memory components, how they are connected. Memory components. Okay. memory components. So what I'm writing, like, no, so let me write all memory components are parallel connection. I'm writing parallel connection. First one is a parallel connection. Parallel connection, nothing but what? CPU is connected to all memory components, all memory components, all memory components. CPU is connected to all memory components. This is what? Parallel connection. Parallel connection. Look this, how this goes. Please understand. If I take two-level memory system. If I take two-level memory system, if I consider it, two-level memory system, if I consider it, okay. So this is what? Level 1. So now suppose if I take level 2, okay. L1 means level 1, L2 means level 2. Please understand. The CPU is there. CPU is there. Fine. Let me take L1, L2. This is CPU. This is CPU. Okay. So parallel, nothing but no parallel bus will be there. Parallel bus will be there. L1, L2, like this. No. Please understand. Each component directly connected to the processor CPU. Separate bus will be there. Separate buses will be there. This we call parallel connection mechanism. Parallel connection. Two-level system. Three-level, 3 bus will be there. 4-level, 4 bus will be there. So that you have to understand in a parallel connection. Now suppose the case number 1, if the processor is connected but all the components, then how we can obtain the average access time? We'll observe. If the processor is connected to memory with a what, level by level, how we can evaluate the what, the average access time? This will observe all of you. Please understand. Okay. Case number 1, right? So now CPU is connected to two memory components, two-level memory hierarchy. I have taken two-level memory hierarchy. I have taken. Please understand how it is connected. Parallelly connected. Please understand. Parallelly connected. Okay. So this is level 1. This is level 2. Okay. Now please understand. Whenever processor gives a reference. So reference, please understand. Processor gives a reference. Reference means address. Please. Processor generate the address to fetch a instruction. The reference can be, please understand, reference can be, so instruction, please understand, instruction, read, please understand. So data, reference can be go for data. The data can be, reading data can happen or writing data can happen, please understand, okay. Reference can go for instruction or data. If it is instruction, we are reading the instruction, writing instruction will not be there. Reading instruction will be there. If the reference goes for data, either reading or writing can happen. We read the data from memory. After executing the data will write into main memory. You understand? Main memory or cache. Reference can go data or instruction. Please understand. Any reference. Whenever reference is generated, that can be checked in L1 or L2. If this present in this level 1, so we call H1. H1 meaning what? What is H1? Hit ratio. What is hit ratio? Hit ratio gives what? Number of hits to total number of references, or number of hits by number of hits plus number of miss. That's simply total number of references you can tell. How it will happen under two-level memory hierarchy, which parallel connection, if I use it, how this will happen, you can observe. Okay. Now see, please understand. Processor will place the addresses into parallelly, both the lines. Parallel it will place. Parallel connection, but parallelly the processor will place address to fetch instruction or data from all the memory components. Getting? So parallel it will go. This level 1. If it is presented, please understand. If it is presented, so this is handout to the CPU. Let's take this time is taken by T1. Please understand, when it is present, please understand, when it is present, immediately this line is ignored. This line is ignored because the data is present, not required to continue searching. It is not required to search continuously. If it is present, this given. Is stop the searching, then given. If this is not present, if this referred word is not present, level 1, this will continue. It won't search, it will continue because already started searching, right? It will continue. So it is definitely present. So that is given to the processor. This takes the time T2. I hope you understand my statement. Clearly I am telling. Processor will place the address into address line parallelly, both the bus parallel it will place. So now please understand, logically this access time of T1 is smaller than T2 because level 1 top level memory is costlier and smaller memory and faster memories. Faster, costlier and smaller. Like bottom level memory or like level 2 or you understand slower memories, less like slower memory, large memories. This we need to understand. So now parallelly placed, right? When the movement is present, it will stop searching, it will given to the processor, taking time almost T1. Access time, please understand. Here is access time. Generally this will vary also. How it will vary? Access time is generally taking address, placing into address bus, searching. So once word is present, we call access. Then after that transfer will happen, but I'm considering placing address and address bus, searching into main memory. When it is it, then we have to read it all together. T1 I'm considering here. Getting? Checking availability, reading and transfer is T1. Here also reading and transfer T2. Fine. Now if I am asking the average access time with this 2 level memory, means simply processor will give a reference. Processor will generate address. Whether address can be searched in level 1 or level 2, but ultimately I should get a data. How much time? What is average time required? What is average time required? 2 level system. Correct? So how we can write it? First, where you are searching? H1. Okay. So please understand, with the example we understand. Suppose processor generated one address now. I am searching here. So first both went. So both parallel went, but I can search first because access time is less. I am searching. If it is present, this line is ignored, given to the CPU. Means it, H1 is it, right? H1 equal to 1. Getting my point? Second reference comes. I am searching here. This also present. So the line is ignored, given to the process. Like this. Total 100 references generated. Please understand. Total how many? 100 references generated by the processor during some period of time. Out of 100, 80 times this is it. H1 is how many times? 80 times it. 80 times it. And remaining 20 times this miss occur, we continued searching level 2. How to write? See, understand all of you. H1. Whenever it miss H1, how much time required? T1 required. T1. But some reference miss, right? Miss how to write? H1 is it means, please, H1 is it. So 1 minus H1 is a miss, please understand. So 1 minus H1. When this miss occur in level 1, when you search into level 2, definitely available or not? Available. 1 minus H2, H1 into T2 I can add. So multiply with H2 is not required because H2 value here. Here H2 value will be what? 1 or not? Always 1. 80 times, suppose out of 100 times, 80 times it nothing but H1 equal to 80 by 100 or not? 80 by 100 nothing but 80% I can say. Now remaining 20% will be where? In level 2 only. You hope you understand the expression. The expression if you see. So 2 level memory hierarchy which parallelly connected, T average access time equal to H1 T1 plus 1 minus H1 into T2. This way you can understand. So this way you can understand all of you, right? Chalo, we'll see this further. Suppose what I am trying to say here, if H1 equal to 1 means 1 meaning what? It in level 1. So what is the T average access time goes? So H1 will 1, right? 1. This 1 means T1 plus 1 minus H1 means 1 0. This is T1 only will get, right? T1 only will get. That's what I understand. If H1 equal to 0, what you will get? So T average equal to H1 0 means what? First term 0, second term means a T2. So this expression goes. Please understand. When it in level 1 or level 2. This is average access time. So this also we can rewrite. So T1 H1 into T1 plus M into T2. M is miss when miss occur. Or 1 minus H1 also can write. So this is the expression, two-level memory system which parallelly connected. Suppose if I ask you, write all of you, please, three-level system if I consider, three-level memory system consider with parallel connection only. For that, can you able to write the value, what expression for average access time? Yes, all of you, please. Let me, so I hope it is visible. So this part is visible, right? Everybody? Yeah, fine. Now look this, CPU is connected to three level, level 1, okay, level 1 system, okay, level 2 system, and level 3 system, okay, L3, level 3, okay. All are parallel, right? Parallel. See now, parallel nothing but separate bus will be there. Access time of L1 is T1, access time of L2 is T2, access time of L3 is T3. Iteration of L1 is H1, iteration of L2 is H2, iteration of L3 is H3. By default H3 equal to 1 only, yes or no? By default H3 equal to 1 only. With this consideration, T average access time with 3 level will be, first where you are searching, you understand, 100 references given by the processor. 100 reference would have searched parallelly all. Like suppose one reference comes, take one reference, first reference. Given placed all 3 buses. So first T1 time is, T1 is smaller than T2, T2 is smaller than T3. Yes or no? This relation good old or not? Now T1 says if it is it, this given to processor, these two lines are ignored. Getting my point? Suppose second case, second reference goes for all, and this level 1 says that miss level 1. So it is not there in level 1. Can we guarantee that if the level 1, if it is not there, definitely is available level 2? No. If the level 1 miss occur, it can be present level 2 or it cannot be present level 2. But I can guarantee if level 1, level 2 not contain, definitely will avail level 3 only, because there is no point level 3 missing happen. There is no point missing happen because such program does not exist. We are beginning, you are started execution nothing, but the program must be in secondary memory, thereby you load into main memory, right? So bottom level memory always should contain the program which you are going to compute it. So there is no point missing at level 3. Getting my point? Now see, I am writing T average. First I am checking H1. If it is it, T1 time required, right? Every time H1 is giving it only, T1 only required. If miss occur in level 1, 1 minus H1. Miss occur in level 1, please, miss occur in level 1 minus H1. Can you guarantee that will be present in level 2? No. I should maintain H2 for this, H2. H2 says it rate of L2. If it is it, how much time required? So T2 time required. Here also can happen miss or not? Here also can happen miss or not? Yes or no? Next. So level 1, first third case, first level 1 miss, also level 2 also missed, then definitely it will be available level 3 or not. So is it required write H3? If you write H3, no impact. If you not write H3 into H3, no impact, no please, because H3 value will be 1 only by default. So this expression gives, you understand? If it is H1 is it, if it is present H1 equal to 1, this will give T1 only, see H1 equal to 1. So this becomes 0, this becomes 0, the T1 only. Suppose second case, if it is only present level 2, H1 is 0, H1 is 0, H2 equal to 1. So this part becomes 0, this H1 is, this part becomes 0. So H1 is value how much? 0, 1, 0, 1 only. H2 equal to 1, T2 comes. So this becomes 0. If both the case miss occur, third one, so H1 is 0, H2 is 0, definitely this will be T3 only. I hope you understand. So this can be generalized with for n levels also you can write down. I hope it is clear. I hope it is clear. Chalo, we'll move on to the case number 2. Let's move on to the case number 2. Okay, case number 2. Look, all of you. Case number 2. Case number 2. Case number 2 is level by level connection. Level by level. Okay. So level by level, ma. Please understand. Level by level, not by parallel. Level by level. With single bus system. So this is what single bus system. Single bus system. Please understand. Single bus system. So parallel bus system is the faster mechanism, but it is costlier. Please understand. If I want to implement parallelism, all memory components, separate buses if you want to use it. So that is a faster mechanism, I can say, because quickly I can get it. But that is costly. Separate bus keeping is costly. So now you understand. Level by level is a single bus system is for cheaper comparison to parallel, but this may be little overhead, means time may takes more than parallel connection. But most of the practical cases, which is preferred, single bus system preferred for few. In between few cases they can connect parallelly, but most all things are sequential only. System level by level only. What is the level by level? Let me take two level system CPU. This is CPU and level 1. Okay, level 1. Okay, please understand. And level 2. Okay, level 2. Now level 2 is connected to level 1 ma. This is level 2 is connected to level 1. Level 1 is connected to CPU. Now CPU is not directly connected to level 2. CPU is not directly connected to level 2. So CPU has to fetch in level 1. Then if you get it, take away. If it is not available, then you have to search in level 2. First data will move from level 2 to level 1. From there level 1 to it is given to the processor. This you need to understand. Differentiation clear. Whenever there is a miss in level 1, now you have to access the data from level 2. The level 2 data need to be transferred into level 1. From there it is given to the processor. Now say, if this data is present at level 1, we call H1, iterate. If miss occur, this will be available, right? 1 minus H1 case it will come. Also you can write H2, meaning is same only. Fine. So with this respect, so now if it is available, so this can be handed out to the processor, maybe taking this T1 time. So now if this miss occur, then will data move from tell me level 2 to level 1. This time take it T2. Please understand. Access T1 is access time, data moving from level 1 to CPU. T2 is access time, data is reading and moving from level 2, transferring from level 2 to level 1. You understand? This is T2. Now to putting together, what is the average access time in this system? What is the average access time? Need to be understand clearly, because it is not like a previous formula. This expression different. How we can understand? You look at the concept. So whenever CPU generated the reference, okay, whenever CPU generated the reference, that reference you have to search in level 1 system. Search in level 1 system. If it is it means what? H1. Correct? H1. If it is it, how much time required? T1 time required. Out of 100 times search, 80 times it is it, means 80 times into T1 required or not. The next case, please understand. Next case, suppose remaining 20 times I search in level 1, that is not present. 20 times additional time required for T2 or not? Yes or no? So first already searched in level 1, it's saying that is miss. Then again T2 required. To transfer from that you have to give it to the processor, right? Now see, I am writing plus. When there is a miss in level 1, from level 2 to level 1 you have to transfer this T2, from this level 1 to processor you have to give T1. This is a different expression ma. You should not confuse. Why I written T2 plus T1? Please understand. I said T1 is a access time or level 1, nothing but first I have to address search. If it is present it, then given to processor. Searching and transferring is a T1. Case number 2, I am searching. This is not available. You are not transfer, not available, not transfer, right? Then I will go to level 2. Read, transfer, full T2 required. Then I have to transfer it. That's what T1 required. So whenever miss in level 1, T2 plus T1 required. When there is it in level 1, so T1 only required. That need to be understand. When H1 equal to 1, how much time T1 only required? See, T1 only required. When H1 equal to 0, so this will be 0, this part will be 0, 1 minus H1 0, T2 plus T1 is required. This need to be understand clearly, all of you. All of you need to understand this one. Okay. So this expression, is for what? 2-level memory system with level by level connection. So T average equal to H1 T1 plus 1 minus H1 into T2 plus T1. Let me simplify this one. H1 T1 plus This is T2 plus T1 minus H1 T2 minus H1 T1. Okay. So these two terms cancel, right? These two terms cancel. So this I can T1 plus, can I take T2 common? 1 minus H1 into, this is T2. Please understand. So I can write that expression also, we can rewrite T average equal to T1 plus 1 minus H1 T2. Okay. This is a simplified expression. Both are same only, ma'am. This either this you can use, this you can use for problem solving, everybody. Look. So now some things we can understand. See how I am going to read a other way. When level by level connection is there, first off I have to whether it or miss, I have to read level 1 or not. Tell me all of you. Please comment. Whether that level 1 it or miss, I have to search level 1 only. So T1 is compulsory. If it is it, T1 only alone required. If it is miss, what extra required? T2 required. Are you getting my point? If it is it, only T1 required. If miss occur, along with the T1, extra T2 is required. That need to be understood clearly with this one. So this also I can rewrite. Please understand. This also I can rewrite. So T average equal to T1 plus M T2. What is M? What is M? 1 minus H1. Please understand. So simple expression. Okay. E2 time plus miss plus T2. M equal to 1 minus H1. Even other way also we can write this one. I will rewrite again. So T average time equal to, okay, it latency. So it latency means time. It latency of L1, plus miss rate of L1. Please understand, miss rate of L1, because miss occur in level 1, right? 1 minus H1 is miss rate of L1 into okay, it latency of L2 also, because it occur in level 2. This also we can write or so T average equal to it latency. I hope you understand L1, because why it latency? T1 is what? Access time of L1. If it is it, we are required T1 times. It latency, time taken to read a data when there is a it, L1. Miss occur, if miss occur, miss rate means the rate of it is miss L1, and miss penalty, penalty of L1. Please understand, everything I written in L1 form only. Try to understand the terminology which I used, because sometime in the questions, especially gate questions, the terminology they used, we should not misunderstand, we should not able to get it. So we should get it. What I am trying to say, when there is a it in level 1, T1 time only required, access it. If there is a miss occur in level 1, miss rate, H1 is it rate, write down all of you, H1 is it rate, 1 minus H1 is the miss rate of L1, If miss occur in level 1, we have to go to L2, right? So no, see, understand the diagram. If miss occur, no, here miss occur. If miss occur in L1, you have to go to L2. So L2 you are going nothing, extra time required or not, that we call penalty of L1. Extra T2 time required to get the data from level 2 to level 1 because of miss in level 1. Getting all of you? So that's why I am writing, no, that I am writing like, no, miss penalty of L1. Because of L1, penalty happen. Penalty means what? Extra time happen. I hope you understand this line. Okay. So either this can be written like this, this can be written like this, or this can be written like this, this can be written like this, or this can be written like this. This is a which we got. Then I rewrite by simplifying this one, T1 plus 1 minus H1 T2 we got, or simply T1 M, you can write miss M1, you can write M1 meaning what? Miss rate of L1, then T2, or in terms of verbal also we can write it. So this is a thing. Suppose 3-level memory system, if I consider 3-level memory system, getting my point? CPU, okay, CPU, L1 memory system, L1, okay. So this is connected bidirectional. in terms of address only, address and data. Okay. Generally address is what? Unidirectional, L2. Then this is connected L3. Okay. L3. Okay. Getting my point. L3. Access time of L1 is T1. Access time of L2 to L1 is what? T2. From here to here is what? T3 I am considering. T3. And this is present, this H1 is hit ratio. This is 1 minus H1. And if you take H2, so this is what? 1 minus H1, 1 minus H2. Like this is level 3. Okay. With this consideration, how to write the expression? Please understand, all of you. Okay. T average. First, where to search? Where to search? H1. If it is present, H1, T1 required. If miss occur, 1 minus H1. Please, if miss occur, please 1 minus H1. Then I have to search in level 2, right? You have to search in level 2. Do you guarantee level 2 compulsory available? No, it can be it or miss. So, H2 have to make. I make open the bracket. H2 have to make. If it is level 2, then see. If it is level 2, then what to do? From here to have to transfer T2 time required. From that you have to give into CPU. So now see. So T2 plus T1 is required. Yes or no? Yes. So in that bracket plus even miss occur in level 2. Then tell me, miss occur in level 2. Miss occur level 2. Then what to do? From level 3 to level 2 you have to transfer. Level 2 to level 1 you have to transfer given to the CPU. So level 3 to level 2, T3 time required, then T2 time required, then plus T1 is required. This is the expression. So this expression for 3 level memory system which are connected level by level, I hope you understand. So this mathematically, if you simplify, you will be getting this one. T average equal to T1 plus, if miss occur in what level 1? 1 minus H1, right? 1 minus H1. So, if miss occur in level 1, extra T2 required or not? Along with T1. Before formula only, right? So, I read enough. So, T1 plus 1 minus T2. This only required. This only we got 2 level. Then if there is a miss in level 1 as well as level 2 1 minus H2, then extra what? T3 required. This is the expression. If you simplify mathematically, this one. So this is same as this only, no difference. This also I can rewrite. So T average, okay, equal to T1. Compulsion T1 is required because whether it miss or hit, you have to search in level 1, right? If it is level 1 hit, T1 only required. Other extra what? If there is a miss rate in L1, extra penalty T2 required. If there is a miss in L1, miss in L2, extra penalty what? T3 required. This is simplest formula you can understand. This also equal to that only. What is M? 1 minus H1. What is M1? 1 minus H1. What is M2? 1 minus H2. That's it. Wow, how verbal I am reading? If there is a hit in L1, T1 hit latency required. If miss occur, miss rate of L1, penalty T2 required. Miss rate of L1, miss rate of L2, penalty T3 required. If there is a miss in level 2, you have to go to level 3. Level 3 the penalty to L2. Understand? T3 is a penalty of what? Penalty of level 2. T2 is a penalty of level 1. That way you can understand. So I hope you understand 3 level system with this, if it is connected, what level by level. I hope it is clear. Chalo, we'll move on to, so case number 3. Case number 3. Case number 3. Case number 3. Okay, little modified of this one, case number 3, all of you. So this is what exploring the spatial locality. Exploring the spatial locality. Exploring the spatial locality. What is the spatial locality? The spatial locality means what? Space, extra space. What is the spatial locality talking about? Please understand. Please understand. Okay. L1, L2, L3 are there. Please understand. L1, L2, L3 are there. Okay. Getting my point, all of you. L1, L2, L3 are there. So let me take it properly. Here is a CPU. Here is a CPU. Getting? Here is a CPU. Okay. Now, so L1 is there. Here is a L1. Please, this is L1, right? L1. Okay. Here is a L2. Here is a L2. Then here is a L3 system. Okay. L3 system. Okay. L3, L2, okay, which are connected, level by level only, right? So level by level connected. Okay, so this is H1 is iterate of this one. This is 1 minus H1 into H2, this L2. Then this is what? 1 minus H1, 1 minus H2. The H3 means 1 only, right? Yes or no? So time taken and reading and writing, like reading a data from L1 is T1, T1, take T1. So this is T1. So if there is it in level 2, then we can transfer into level 1, right? So this is what T2 was in that. So this is taking what? To transfer one word from level 3 to level 2, T2. One word transfer, please all the way. So far whatever I discuss, T1 represents for accessing one word with respect to that particular memory system. L1, L2, L3, what level by level connection, connected, basic information given. What is the spatial locality means here? Whenever, please understand, whenever reference comes from the CPU to fetch instruction or data, right? Data, reading or writing, please understand. I am trying to search in level 1. Okay. I am trying to search in level 1. If it is it, please understand, I am giving to the processor. Fine, happy. T1 time only required. Second case. Whenever reference comes, I am trying to search in level 1. If it is not there, if it is not present, means miss. A miss occur, I have to go and search that particular word, and the word is transferred from level 2 to level 1 given to the processor. This is what previously discussed. Spatial locality means, so locality of reference need to be transferred. What is locality of reference here? Suppose you are reading, suppose here is some data is there, please understand. There are two words are there, word 1, word 2, two words are there. Okay. You are looking for one word, this word is the word number 1. Here miss occur, I am searching here. Now spatial locality saying that along this word 1, adjacent word also you transfer, adjacent words also you transfer. What the benefits are? Priorly if you transfer, in the future, if processor refer to word number 2, that is going to be available here. So means for future penalty is going to be reduced. If I explore, if I use the spatial locality, and in advance some adjacent data need to be transferred to next level, so that in the future, so that is going to be it here. So total average access time going to be reduced here. So will it happen, sir? Yes. Example, array, when the program is reading for action array elements, then I equal to 0, first element, next two words can be transferred. Definitely when I equal to 1, I equal to will be it or not? Yes sir. So now see, this two words I am transferring here. So two word block, no, here I am writing now, two word block. So two word block is transferred from level 2 to level 1. From there only one word is given to the level 1 processor. Suppose when you are searching level 2, that level 2 also miss occur, then what can be done? From level 3, some large block we can transfer. Let's take the four words are the word 0, word 1, word 2 and word 3 is there. Please understand here, four words, please understand, four words transferred from level 2 to level 1, so level 3 to level 2. From there two words are transferred from level 2 to level 1. From there one word is given to the processor. This is what spatial locality means. Spatial locality nothing but you came for word number 0 only. Along with the words with 0, some other words also transfer in next level, so that in the future it can be reduced. Are you getting my point? So this is the what spatial locality is talking about. Now one word transfer how much? T3. How many words you are going to transfer here? 4 word. 4 into T3 will be happen. One word transfer is T2. How many words you are transferring? 2 words, right? 2 into T2 it will happen here. Here only one word should transfer, that's what T1 only. So with this respect, if I want to write the expression T average access time equal to, okay, simplified form only I am writing now. So H1, so normal already, then simplify H1, T1 required if it is available level 1. If miss occur in level 1, 1 minus H1, right? Yes or no? 1 minus H1, right? 1 minus H1. I have to check H2 also. H2, if it is it, level 2 to level 1 you transfer. I am writing TB, block of 1 you have to transfer, plus T1 will be there, right? If miss occur in level 2, then what to do? So TB to block 2 you have to transfer, more words of the block you have to transfer. Level 2, from level 2 TB1 will be transferred, from there T1 is given. So this is the expression, this simplified expression if I want to write it. So this is what? T1 plus 1 minus H1. So now when there is a missing L1, L2 say you have to come, that is what TB1 it is coming, TB1 comes. When there is a missing L1, when there is a missing L1, 1 minus H, missing L2, so TB2 will come, TB1 will be, T1 will be there. So this is average access time, both are same only, mathematical simplified. What is the TB1? So TB1 2 times of T2, where TB2 is what? Block of 2 what? What is the meaning? 4 times of T3, because 4 words I mentioned. In the example, 4 words are moved here, 2 words are moved, that's you have to understand here. So this is a 3 cases, 3 or 4, 3 cases we have seen. There are 3 cases of connectivity. Parallel connection, level by can be only temporal locality, and second was spatial locality. I hope you understand. So we'll see one question, 1 or 2 questions we'll see in this area, all of you. So let me write the question, one question. Consider, all of you, consider 2-level memory system. Consider 2-level memory system. 2-level memory system. Consider 2-level memory system. Okay. L1, L2. So L1 is, please understand, I am writing here. Here I am writing. So consider 2-level memory system. So L1 is twice faster than L2 memory system. L2 memory. Twice faster than L2 memory has 80% hit ratio with 20 nanosecond access time. 20 nanosecond access time. 20 nanosecond access time. So this is a given data. Question number 1. So what is the average access time? What is the average access time with a 2-level system? And second question, what is the throughput? So throughput of the system, throughput of the 2-level memory system. 2-level memory system, they're asked. How to solve this question, all of you see? How to solve this question, all of you observe? Okay. 2-level they given L1, they said L1 is please understand, L1 is 2 times of faster than L2. Can I write like this, L1 is 2 times faster than the madam. L1 equal to half of the L2. Yes or no? 2 times of faster. So now T1, T2 is access time. So now say L1 is twice faster than L2 memory, has 80% hit ratio with 20 nanosecond. L1 access time is what? 20 nanosecond. It is 2 times faster than L2, nothing but T2 is slower or not? So T2 is going to be 40 nanosecond. Yes or no? Hit ratio how much? 80%. H1 is hit ratio 80%. Now you have to substitute in the expression T average access time equal to. Now question comes, sir, should I follow the parallel connection or serial connection, level by level connection? In the question they did not mention anything. By default is a parallel connection considered, because that is faster, right? By default you take the faster parallel connection. In the question mentioned the words, some keywords I am going to give, please understand. I am going to give some keywords to identify whether level by level or like parallel connection. If nothing is mentioned, go with the parallel. If they say I am searching something level 1, if there is a missing L1, I am going to search level 2. Or some extra words are transferred from level 2 to level 1. So this kind of keywords if present, then we can go with the level by level connection. Otherwise, parallel connection only, right? So now substitute in the expression. So T average access time equal to H1 T1 plus 1 minus H1 into T2. I have to consider H1 is what? 80% into 20 nanoseconds plus 20% into 40 nanoseconds. Fine. So this gives how much? 0 cancel, right? 8 to just 60 nanoseconds plus. So 0 cancel 8 nanoseconds, right? This is giving me 24 nanoseconds. So T average access time, please understand, is 24 nanosecond per word. Please understand. From two-level system, whether a reading instruction or reading a data or writing a data, whatever type of reference generated by the processor, two-level system required almost 24 nanoseconds required per word. Why 24 came? Because this is taking 40, this is taking 20. Because iterative level 1 is high, 80%. If 20, instead of 80%, 90% is there, it will reduce so much more. Yes or no? Because it may equal to access time level 1. If iterate should down, suppose 60%, this will increase. That's what I said you. Iteration of the level 1 system is high, average access time is down. If iteration is smaller, average access time will increase. So this we can understand. So the question number 1 is like 24 nanosecond per word. What this has second question? Throughput. Yes, all of you. So start think about throughput. What is throughput here? Generally, from the operating system point of view, you might have studied throughput. Throughput nothing but number of process completed per unit of time. Here is a throughput. Number of words transferred per unit of time from the memory system. Two-level memory system. What is the throughput of two-level memory system is how much data transferred per unit of time is a two-level, what throughput here. Now, how can I calculate? You see now. Here 24 nanoseconds required to one word, right? Yes or no? One word how much? 24 nanoseconds required. Suppose if I allow system to transfer 1 second time, how many words I can transfer? That is the throughput only. So 1 word into 1 second, 1 word into 1 second by 24 nanoseconds. So this is a throughput. So words per second, words per this way, keep it. So what I can write 1 by 24 into 10 power of minus 9 seconds. Second cancel, words will be there. So this simplification 10 power of minus and upside you send. So can I write 1000 by 24 into 10 power of 6. Word will be there, words per second I'll keep it. So 1000 by 24. So that you can calculate. So I can write 1000 by 24. So if you want to calculate, we can see. Thousand by 24. This gives 41.66 approximately 42 million words per second. Million words per second can be done. This is a throughput of the system. So this is a throughput of the system. I hope you understand my point, all of you. Fine. So let's see another question. Let's see another question, all of you. Look this second question. Look the second question. Consider 3-level memory system of the following specifications. T1 is at 10 nanoseconds per word, H1 is at 80%. T2 is what? 15 nanoseconds per word, H2 is what? 90 nanosecond. T3 is 200 nanosecond, H3 100% they given. Anyway, 3-level system, if I say bottom level memory system has what? Highest iteration, that 100% iteration. Now see, if the referred word is available in level 1 memory, it is hand over to the processor. If it is not available level 1, a two-word block is first moved from level 2 to level 1, and from level 1 it is given to the processor. If it is not present even in the level 2, a 4-word block is first moved from level 3 to level 2, and associated block is moved from level 2 to level 1 given to the processor. What is the average access time in this system? What is the throughput of the 3-level memory system they given? Now see, this is level by level or not? How to understand, sir? See, when there is a miss in level 1, 2 words are transferred from level to level 1. When there is a miss in level 2, 4-word block is transferred from level 2 to level 3 to level 2. From there, a 2-word given from level 2 to level 1 given to the processor. This is what spatial locality consideration. Yes, this directly mention clear this level by level connection only. So we can use a formula. What is the formula? T average access time equal to T1 plus 1 minus H1 into TB block 1 plus 1 minus H1 into 1 minus H2 into block 2. What is the T1 time? T1 time is what? 10, 50, 200 nanosecond, right? 10 nanoseconds. Plus H1, 80% means miss rate was 20%. 20%. T2 access time, 50 nanosecond. So block 1 means how many blocks are moving there? 2 word block. 2 times of 50. Plus 1 minus H1 is 20%. Into 1 minus H2. What is H2 iteration? 90% means what? Miss rate is what? 10%. So 10% to 4 times of 200 nanoseconds. Because 4 word block you are transferring. Need to simplify. 10 nanoseconds plus how much this value? This is 100. 100 means 0.2. So this is 0.2 into 100, right? 0, 0 cancel. So 20. 0.2 into this is what? 100 nanoseconds. 100 nanoseconds. 0, 0 cancel. 20 nanoseconds will get 20 nanoseconds directly. 20 nanoseconds plus. So this 0.1, 0.1. This points cancel, right? 2 to 4, 8 to 16 nanoseconds. 16 nanoseconds, right? So this is 30, 46 nanoseconds will get. 46 nanoseconds per word. Per word is average access time. So what is second question? Throughput. Throughput. So throughput equal to 1 by T average access time. I can generalize because same thing did. So 1 by 46 nanoseconds means 1 by this time 1 by. So this I can write 1 by 46 into 10 power of minus 9 seconds. This we can write 1000 by 46 into 10 power of 6 words per second. So this gives approximately 22 million words per second. You check it 1000 by 46 how much it will give. Thousand by 46, 21.7 means 22 millions. Yes, 22 millions words per second. This is the throughput of the 3-level memory system. This way we can able to solve it. I hope you understand the memory hierarchy clearly, because I started what is the memory hierarchy, what are the types of memories, their arrangement we have seen, purpose means how the concept memory hierarchy came into picture, what is the importance of the cache memory that I have observed, how this will reduce average access time further, the various characteristics of the memory hierarchy we have seen, followed by performance. That's this performance of the memory are completely given by hit ratio, how to get the hit ratio. And this connection also we have seen, finding the average access time in a system, consideration, parallel connection, level by level connection, and exploring the spatial locality. So this is completely fine. With respect to question comes, you can able to answer it. I hope you understand. This session definitely is going to be help you lot to understand these areas. And in the next session, I'll coming up with another topic called main memory. We'll see. I mentioned memory organization. I'll discuss memory hierarchy followed by main memory, then followed by cache, secondary memory. So in the next session, we'll see the memory, main memory, and the next again coming up cache and secondary memory will continue. In this series, entire memory part will cover. Then after that, pipeline we'll see. So all of you, those who missed this session, please watch. Initially 2 sessions I have taken, so which is available in the same like in this YouTube, where I discuss the floating point number representation, the basics part I covered. Fine. So thank you so much, all of you.